Hello everyone. In this video, we will provide the training course on AWS certificate for Generative AI Developer Professional, where in this video we'll continue to talk about the implementation and the integration part, which covers 26% of the questions list in the exam. We'll start with Amazon API Gateway. As a definition, it's for creating, publishing, and managing APIs. It handles request routing, authentication, rate limiting, and request and response transformation. You define REST APIs, HTTP APIs, WebSocket APIs, and the API gateway handles the infrastructure for this. For generative AI applications, the API gateway is the front door. It exposes your generative AI functionality as APIs that applications can call. You would use it to provide REST APIs for the foundation model invocations, implement WebSocket APIs for streaming responses, add authentication and authorization, define rate limiting API calls to prevent abuse, and transform requests and responses. Actually, REST APIs are full featured with request validation, caching, and the API keys. But HTTP APIs are simpler, cheaper, and good for straightforward proxy scenarios. But WebSocket APIs are for bidirectional communication, useful for streaming foundation model responses. API Gateway integrates with Lambda, step functions, HTTP endpoints. For generative AI applications, you would typically have API Gateway call Lambda, which is in calls Bedrock or your generative AI services. API Gateway handles the HTTP layer. Lambda handles the business logic in generative AI apps application. Request validation lets you define schemas and reject invalid requests before they reach your backend. This is quite useful for generative AI APIs where you want to validate prompt parameters, token limits, or model selection in the foundation model of the Amazon Bedrock. Next, we'll talk about AWS AppSync. AppSync for building GraphQL APIs. It handles GraphQL query parsing, schema validation, and data fetching from multiple sources. You define a GraphQL schema, configure resolvers, and AppSync handles the API infrastructure. For generative AI applications, AppSync is useful when you need flexible queries and real-time subscriptions. GraphQL lets the client request exactly the data they need, which is handy for generative AI applications where different clients might need different fields from foundation model responses. AppSync supports real-time subscriptions over WebSockets. Clients can subscribe to data changes and receive updates automatically. For generative AI applications, you might use subscriptions to push model responses to clients as they are generated. Resolvers connect GraphQL fields to data sources, Lambda, DynamoDB, HTTP endpoints, or other AWS services. For generative AI applications, you would typically use Lambda resolvers that call Bedrock or your generative AI services. The difference between AppSync and the API Gateway is that AppSync is specifically for GraphQL. If you need GraphQL, use AppSync. If you need REST or WebSocket APIs, you would use API gateways. For generative AI applications, API gateway is more common, but AppSync makes sense if you are building a GraphQL based applications. Next, we'll talk about AWS AppConfig. AppConfig is for managing application configurations and feature flags without deploying new code. It's a part of AWS Systems Manager and lets you change application behavior in production by updating the configuration data that your application retrieves at runtime. Use AppConfig when you need controlled rollouts and monitoring. For generative AI applications, AppConfig is useful for controlling behavior without redeployment. You might use it to switch between foundation models, for example, from Claude to versus Llama based on features flags, adjust prompt templates without code changes, control which user get access to new generative AI features for gradual rollout, tune model parameters. You can change up temperatures, max tokens in production, enable or disable expensive features based on cost or performance, and implement A/B testing for different prompts or models. AppConfig supports two types of configurations: features flag and freeform configuration data. Features flag are Boolean toggles on and off with optional attributes. Freeform configuration can be JSON, YAML, or any text format stored in AppConfig hosted configuration store, S3, parameter store, secret manager, or SSM document store. The architecture includes application namespace, environments for development, staging, production, configuration profiles, what to deploy, and deployment strategies, how to deploy. You create configuration profiles, define your flags or configuration data, and deploy it to an environment using a deployment strategy. Actually, deployment strategies control rollout speed, and safety. You can deploy instantly to all targets gradually over time. It's time canary deployments or with automatic rollback if CloudWatch alarm triggers it. For generative AI applications, gradual rollout is quite useful. You can enable a new model for 10% of the users, monitor performance, and roll back if any issues occur. Your application retrieves the configuration using AppConfig data API. It establishes a configuration session with a start configuration session, then pulls get latest configuration periodically. AppConfig caches configuration data and all returns updates when configuration changes, keeping API calls efficient. Multivariant feature flags are supported for advanced use cases rather than simple on and off. You can define multiple variants, example Claude, Llama, GPT-4, and rules that determine which variant to return based on user attributes. This is useful for A/B testing different models or prompts with specific user segments. The difference between AppConfig and the parameter store is that AppConfig is designed for dynamic configuration with deployment strategies and rollback, but in parameter store is for static configuration and secrets. Use AppConfig when you need controlled rollout and monitoring, but you use parameter store for configuration that rarely changes, like static data. For generative AI applications, AppConfig is particularly useful because model behavior and the costs can vary significantly. Being able to switch foundation models, adjust the parameters, or disable features without redeployment gives you operational flexibility when dealing with foundation model changes or cost spikes. Next, we'll talk about Amazon S3 vectors. It's a new storage option for vector embedding, introduced as cost-optimized alternative to dedicated vector databases. It's part of S3 but uses a different bucket type called vector buckets, specifically designed for storing and querying vectors at scales. For generative AI applications, S3 vectors is useful for RAG implementations where you need to store millions or billions of vector embeddings cost effectively. It reduces vector storage costs by up to 90% compared to dedicated vector databases, whilst maintaining sub-second query performance for infrequent queries and around 100 milliseconds latency for more frequent ones. The architecture uses vector buckets, new S3 bucket type, that contain vector indexes. Each vector bucket can have up to 10,000 indexes, and each index can store up to 2 billion vectors. Use dedicated S3 vector APIs to store, access, and query vectors. It is not the same as storing JSON files in regular S3 buckets. S3 vectors integrate natively with Bedrock knowledge bases. When creating a knowledge base, you can select S3 vectors as your vector storage instead of OpenSearch Serverless, Aurora, or other options. Bedrock automatically manages the embedding, chunking, and synchronization. This is the simplest way to use S3 vectors for RAG applications. Metadata filtering is supported also. You can attach key value pairs to vectors and filter queries based on conditions like data, categories, or user preferences. This is quite useful for multi-tenant applications where different users should only see their own data. S3 vectors also integrate with OpenSearch service for tiered storage strategies. You can store long-term or infrequent access vectors in S3 vectors for cost optimization, whilst keeping high priority vectors in OpenSearch for real-time query performance. This hybrid approach balance between the cost and performance. The difference between S3 vectors and OpenSearch serverless is cost and the query performance. S3 vector is optimized for cost with sub-second queries, whilst OpenSearch serverless provides milliseconds latency but costs more. For RAG applications with infrequent queries or massive vector datasets, S3 vectors is more cost effective. For real-time application requiring very latency, in this case, OpenSearch is better. Actually, S3 Vectors is currently available in 14 AWS regions and uses the same durability and availability as standard S3. It supports server-side encryption with S3 managed keys or KMS customer managed keys. Thank you guys for watching this video. I hope you like the video content by clicking the like on the video. And if you have any questions, you can comment on the video. And please subscribe to my channel so that you can follow up for the next videos we'll generate for this course. Thank you.